Hello, we're going pretty fast today. I just finished with Andre, and the whole one continues with Patrick Koch. I'm sorry if I am not pronouncing that correctly. So,
That's fine.
okay, you will tell about yourself more and teach us, I believe. So, Patrick is a DevOps engineer, a blogger, a lecturer at AVL List, and then known as Azure hero in some specific communities, I assume so. I am Uldis Carlos Karlauskis from the Latvia DevOps and Agile community. So we are happy to keep to help the conference out. And then moving to you, Patrick, you are gonna tell us about kind of legacy applications, but already containerized ones, as I understand. So
Yeah,
can
right.
your slides to the screen, and the stage is yours.
Yeah, thanks a lot for the introduction and welcome to my session, Migration of a Containerized Legacy Application to the Cloud. Don't give up just because it's legacy. So it's a story about, yeah, our cloud migration of, one of our popular software applications, which were introduced a long time ago. And yeah, I would like to go through some obstacles which we experienced, and simple some experience which we had during the cloud migration. I would like to start with a short introduction, as I was, as I got a lovely introduction already. So hello again, my name is Patrick Koch. I'm a DevOps engineer working at AVL List. Our business also of AVL is the automotive industry. So our probably most well-known products are, for instance, engine test beds or general test beds. So to put the car on it, to conduct several tests with regards to the speed, acceleration, emissions, etc. But as you know, the automotive industry is in a transition, and so we are, and therefore we are currently, or not just currently, so we are focusing and doing investigations on e-battery, e-fuel, autonomous driving assistance systems, and so on. I am from Graz, which is the second largest city in Austria. For those who don't know Austria, it's the country between Germany and Italy. And if you still don't know Austria, then I always tell the people, hey, that's the country from which the Terminator Arnold Schwarzenegger is from. And latest that, Austria is well known. Feel free to contact me via Twitter, LinkedIn. I'm glad if you visit my blog, Patrick Koch Dev. I'm also quite active with regards to the open source communities. I love to do experiments with Azure and with infrastructure as code, especially with Terraform, and to try to share my knowledge here. So that's about me. So glad to be here. And that's what you can expect from my session today. So we already finished the introduction. And afterwards, I will switch to the second chapter. What happened before the cloud? So I would like to describe at first our initial situation before we started our cloud-related adventures. After that, the third chapter is about the challenge. So our cloud migration of our legacy software application. So why did we do that? What was the result? Which obstacles did we face? And why the hell did we use Windows containers? After that, I will switch to chapter 4. So what will happen based on the results of our cloud migration journey. So the next logical steps, finally Linux containers, and I will finish the session with a conclusion and an outlook. And of course, afterwards, there will be the question and answer session. Okay, let's jump into the topic. What happened before we tried to migrate our application to the cloud? And I would like, therefore, to introduce you AVL Concerto. That's our legacy software application. No worries, it won't be a promotion of that, but just to get a better feeling about our initial situation. So imagine you have it's a legacy software application. It was introduced or the development started almost 3 decades ago. This means we have a huge technology stack, including a lot of unmanaged code. So we have, as you can see, a lot of files, almost 3 million lines of code, many customers, many users, and they still rely on the application. And how dare us if we do any API change? So they, of course, rely on it, and they won't change it, of course. And imagine the situation that after 3 decades, you get the request, okay, maybe it would be a good idea to get your application running in the cloud. And then you think, okay, that's interesting. I never got this request. Would it work? 3 decades so far, we didn't do it, but maybe it's worth a try. And to get another or a better context about Concerto, about our legacy software application, what's the purpose of it? That can be seen here on that slide. So here on the left, you can see an engine testbed. So imagine a validation engineer comes to work and he puts an engine on this testbed to run a lot of different tests to get data with regards to the speed, the acceleration, the emissions, and so on. So I'm, of course, not a specialist with regard to that. But a validation engineer would run those tests the whole day. And then you get a bunch of data out of it. And this data will be some kind of input for Concerto to run scripts against the data to get reports, including some fancy diagrams, as you can see here on the right, to get tables, to get reports. So that would be, for instance, a final result for a customer. So he runs at first the tests against the whole car or against the engine, and then he gets a bunch of data, and we need to do a post-processing of this data, and that's the purpose of Concerto. And this works great, and this worked great, and therefore you probably no wonder, as it works, why do we need to go to the cloud? It seems to be okay. And you can see the answer here on the right side. But at first, again, here on the left, the initial situation, a testbed with an engine on it. You're running tests against it, against the engine. So the engine, so for instance, a combustion engine would be the unit under tests. And after running the test, you of course need to replace the engine with a different one. And it starts all from the beginning. You get a bunch of data and you will do a post-processing with Concerto. Here on the right, you can see the future or already the present of our new use case. So the guys which you can see here on the right side, those are called battery testing chambers. So one battery testing chamber contains several batteries. Each battery contains several modules, and each module contains a huge amount of battery test cells. And this, a single battery test cell, would be our new unit under test. And according to the amount of data which we get out of testing one single battery cell, this can be compared with the amount of data which we get from a single combustion engine. So this means that testing one battery would mean that a single guy couldn't do it in a manual way in that time, so within 1 day. And we get much more data. So we now have some kind of big data in comparison. And this also means that one single Concerto instance can't do that anymore. So therefore we need to scale up Concerto. So we need not just one instance, we need several instances, maybe hundreds. To be honest, though, it's still not that clear. But we definitely know that one single Concerto instance, as we know it, wouldn't achieve that. So therefore, we need to introduce automation and a scaling of our Concerto instances. And the keyword scaling, already refers to some possible, let's call it tools, maybe like Kubernetes, to get the instances scaled. And of course, we need to introduce automation. And therefore, we thought, okay, we need to do it in the cloud. We need for instance, a Kubernetes cluster in the cloud. We already know a customer, or let's imagine that some customer don't have that huge infrastructure or that IT departments, for instance, to run a Kubernetes cluster on-premise. And therefore we decided, okay, if we would like to do that new approach, then let's try it in the cloud. And what has to be done before any kind of implementation starts? A cloud migration strategy. And when we thought, okay, let's try now the adventure to migrate to the cloud, we had 2 different cloud migration options in our minds. So refactoring, rebuild here on the left, and lift and shift here on the right. And as you can see, we have decided for doing the lift and shift, so putting the application as it is in a container and gets the container run on a Kubernetes cluster, for instance. Why did we decided against a refactoring and rebuild at that point of time? To be precise, we thought, okay, it makes more sense, or we are curious what would be the big picture. So which cloud resources would we need for a new use case? And we thought, okay, if we now start with a refactoring and a rebuild of our legacy software application, it's maybe a never-ending story, because you can adapt all the components in a very special way, but where would it end? And therefore we thought, okay, let's put Concerto as it is on a container, and that's the next great point, which for which we tended to choose a lift and shift approach. Lucky us, Windows container existed. So our legacy software application is a Windows application, a Windows desktop application, and therefore we didn't have that much effort to start. So we put Concerto as it is on a Windows container. We could successfully run it on-premise, so the containerized Concerto, and that was a good starting point. So we had now finally our Windows container running Concerto, but what would be the next step? We thought, what would be, how does the architecture would look like for a new approach? And here on the right, or here, the huge cloud here on the right, would be the managed cloud service, for instance, Asia, and we also migrated to Asia. And here, these orange icons here on the right, that would be a Concerto instance. And there are 3 guys here, as you can see. So this would mean that we are able to scale. And the requests would come from a so-called message broker. So each request would result into a calculation, which would be done by Concerto. And finally, we will get for each calculation a corresponding report. So a similar result which you can see before at the previous slide. So a report including tables, diagrams, so a result of a calculation which you get out from the input data which you got from a test run, for instance, from an engine testbed, but of course now also from a test run which run against a battery test cell. And this data or these files which include this data can be located, for instance, at a share or at a database. And therefore here on the left of the managed cloud service, you can see a database. So you get the data stored in a database. Concerto gets this data as input and generates a report. But getting some discrete or sensitive data into a cloud aren't that good news for all. Therefore, we also thought, okay, let's also try to ensure that we can get the data also from a database which runs on-premise, so which is not included in the cloud. But for the very first approach, we just focus to have all the components in our managed cloud service. And we tried our very first adventure here in Asia. And we didn't want to invent something new. We thought it would be good to rely on best practice. And lucky us, Microsoft already provides some kind of solution ideas. And that guy, which you can see here, this architecture fits well to us. Because here on the very left, we have the existing application, which would be Concerto in our case. We containerized it on a Windows container, so we get the final container image, which will be stored and managed on an Azure container registry. And by using here at point number 2, the dedicated CLI commands, we derive workloads on an Azure Kubernetes service. And each workload, there we get as a components, the different pods, which includes the container, and each container, on each container there runs a Concerto instance, which does a specific calculation. And in addition, as part of this architecture, we also could have, for instance, a database from which we get the input data for Concerto. So we thought that's a good idea. Let's try to get an Azure subscription, and let's try to provision the Azure Container Registry to put the container image on it. Let's try to provision an Azure Kubernetes service. Let's provision an Azure virtual machine. There we put a so-called license server on it to get more context. So Concerto is just able to start up if it gets some kind of license features, and these license features can be requested from a license server, and a license server can run on a virtual machine, for instance. So we would derive a lot of containers as part of the pods, and each container does a calculation, and we would get the final result, for instance, on an Azure file share. And as you can see, the red marks here, we had some troubles there, because it's one thing to provision the resources on its own, so that the container registry, the Kubernetes service, the virtual machine, the file share, etc. But the interesting point is, of course, they need to work together. So we provisioned all of the necessary resources, tried to apply a workload, and nothing happened, because we had a lot of, let's call it obstacles, according to number one. So the connection between the container registry and the Azure Kubernetes service. We simply didn't attach the container registry to the Kubernetes service. So the Kubernetes service wasn't simply allowed to pull the container image. That was obstacle number one. What about obstacle number two? So here the connection, let's call it connection between the Kubernetes service and the container. That thing here, I would simply refer that it wasn't possible to schedule a container, a pod to be more precise, at the Kubernetes service. So I've told you that it's about having Windows containers. Therefore, of course, we also added to the Kubernetes service a Windows pod, a Windows node, sorry, to get the Windows container instances run on it. But it wasn't scheduled on the Windows node, because we simply missed an important deployment rule at the YAML, which represents the deployment rules for our workload. So if you have a Windows container workload, you have to explicitly tell the workload that it's about a Windows, and please be so kind and get scheduled on a Windows node. So if you don't do that, and if you already have a Windows node, despite from a Linux node, nothing would happen. So even then, the Windows container workload wouldn't get scheduled. And at obstacle number three, we couldn't get a connection to our license servers, but that's a real IT sysadmin problem which we faced. The thing is, we as software developer, in contrast to our IT colleagues, we never set up a license server on any virtual machine, and therefore we simply didn't consider any firewall rules. And yeah, this led to a lot of obstacles which we faced and which we had to solve in a very painful way. But in the end, we get it run, and we were happy about that. And I would like to show you how does it look like in real. So that guy, which you can see here, would be the Kubernetes service, which we named Concerto-AKS. And here at the PowerShell, you can see that it's possible to, what does it look like if we apply two different workloads against the Kubernetes cluster, which would result to two different pods running two different containers, in which Concerto is running in an automated way, getting the data, for instance, from an Azure file share or from a database, which is also provisioned in the Azure subscription. And in the end, I'm sorry, to get get it on the jobs level. So we decided to have jobs as type of the workloads, because Concerto just needs to do a calculation, and if the calculation is done, then please feel free to terminate. And here you can see that two different workloads are running, which would result to two different reports, which would be the final result, for instance, for a customer. Here at an Azure file share, you would get different directories, and each directory would contain a PDF, which would include the very same report which you would get when you run Concerto in a manual way by doing the very same calculation. And that would be the result of our cloud migration journey. And we succeeded there, and we got somehow the big picture. We're aware which resources which we would need, for instance, an Azure Kubernetes cluster for scaling Concerto. And the next thing would be to, as we are now aware which resources which we need, how can we get it provisioned in a fast way and in a repeatable way? And therefore, the next thing was to introduce infrastructure as code. And there we decided to do it with Terraform. So this means all the resources which we would need to provision would be written by the dedicated Terraform configuration files. So in each Terraform, in one Terraform configuration file, we would add the proper statements, or the respectively Terraform blocks, for instance, to provision the Kubernetes cluster, the container registry, etc. And of course, it would be much greater if the provisioning would be done with a pipeline in an automated way, and there Azure DevOps has a great support for Terraform. And yeah, that would be an example. So here, for instance, you would see two different resources. So at first, a resource group, and here the bigger block. This would be an Azure Kubernetes cluster, which can be provisioned by using Terraform. And the good thing is that it's repeatable, and you can provision the resources when you need it, and you destroy it when you don't need it, for saving costs. And it's also great, so especially by having some kind of cloud migration journey as we had, you have to do a lot of experiments. And at the beginning, we provisioned the Kubernetes cluster in a manual way, and of course, nobody wanted to touch it because nobody wanted to destroy it, or nobody wanted to be the bad one to ruin the configuration. This can't happen if you do it, for instance, with infrastructure as code by using Terraform. You always have the very same configuration, for instance, of your Azure Kubernetes cluster. And therefore, Terraform, respectively, an infrastructure as code approach helped a lot. But now I would like to switch to the next chapter. So what comes next after having a successful proof of concept and after introducing the infrastructure as code approach? On a previous slide, I've told you that we choose lift and shift at that point of time, but we are aware that we need to refactor Concerto somehow to make it more performant, to get it run on a container which will be hosted in Asia, for instance. And therefore, now we are also refactoring our legacy software application, which would mean that here on the left, the Concerto as Windows component will be the past, and we just pick the stuff which we really need for our new future use case, which will be an automated use case, which will be hosted in a cloud environment. This would mean, in our case, we would pick our native data management subsystem and try to get it run on a Linux container. So we throw away all the stuff which we don't need anymore. So the native user interface, the managed user interface, and so on. And we focus on things which we really need for the new use case. And on the next slide, you would see our future architecture. So as you can see, we have some components in Asia. So for instance, the Azure Kubernetes service. In addition, we would have Prefect as a workflow automation tool. And how would the new use case would look like? So imagine you would like to call a specific function of Concerto, which has been proven to work probably for 3 decades. But as it's about big data with regards to the e-batteries, Python is a good approach, and therefore the Concerto functions would be called inside, so out from a Python script. So we would call a specific Concerto function from a library in a Python script, and each function of the Python script, for instance, would correspond to a prefect flow. So prefect would be deployed on the Azure Kubernetes service. Prefect handles the workflow. So this means, for instance, that each function which would be part of a Python script, which would call a specific Concerto function, would correspond, would get at first to the prefect component, and prefect would derive a so-called prefect flow, and the prefect flow would result in a in the end in Kubernetes pods, which would again run, for instance, a Concerto. And there we again get the final reports for the customer. And here finally on this slides, I would, as some kind of recap, I would like to go through some milestones of our cloud migration journey. So it started already somehow in the year 2019, at which we did our containerization of Concerto. So we thought, let's try to get Concerto on a Windows container, as the containers are somehow promoted at that time, or latest at that time. But in the year 2020, we focused more on Kubernetes and the Azure DevOps pipelines, so to get the CI/CD infrastructure, so to build the container image, to deploy it in an automated way on a Kubernetes cluster, which we had on-premise. And finally, in the year 2021, we started with our cloud migration journey. So that was the year at which we started with the very first Azure subscription and tried to get the Concerto container hosted in the cloud, tried to get it run on an Azure container Kubernetes cluster. Again, in the year 2022, as you can see, we are focusing to get Concerto ready on Linux and to consider a Python use case. And here in 2023, so this year, we are now focusing more on which resources which we would need in addition to get the whole architecture for the automated use case in the cloud run, which would contain SQL databases, which would need, for instance, SCADA for doing an autoscale and so on. But this also means that our cloud migration journey is still in progress. And of course, we are still failing somehow, but we are still learning. And I think we do a lot of progress. Of course, some things are still unknown to us, but the whole story also means that also a legacy software application, which was established 3 decades ago, could be part of a modern, of a cloud native architecture. And this leads me to my final slide, a conclusion, some, let's call it some key learnings from our cloud migration journey. So the very first one, decide for a cloud migration strategy before you do any kind of implementation before. So for instance, would you like to already start with a refactoring, with a rebuild of your application, or would you tend to have a more the lift and shift approach, for instance? Maybe the next thing, avoid to start with a too complex implementation. So for instance, consider if you really would like to start with a Kubernetes cluster, which is, I would say some kind of complex infrastructure. There are many more possibilities to get your container being hosted in the cloud. Think of serverless services, for instance. In context of Azure, it would be, for instance, the Azure Container Instances or the Azure Container Apps. The third key learning, don't do manual provisioning, use infrastructure as code. So this would mean to, for instance, try it with Terraform to be able to provision a repeatable environment when you need it and destroy it when you don't need it anymore. Try to save costs and try to rely on repeatable environments. Of course, it would take much more time in the beginning, but I think it's worth it. And finally, be aware of the costs, of course, in the cloud. Try to already monitor them, try to estimate them before there exists a lot of free tools. And finally, I think it's a lot of fun doing stuff in the cloud, doing DevOps, for instance, on Azure. At least I've enjoyed it, and I hope you enjoyed my session. And now I would be ready for questions. And thank you a lot for the attention.
Yeah, thank you, Patrick. Thank you very much. That sounds as quite a journey you had there. And then while we are waiting for a few more questions in the chat, I want to ask you the typical question, which is kind of asked after every project or after every failure or a win. So if now we would be able to go back in time, but you keep your knowledge and your day one on this project, what you would have done differently with the knowledge what you have today?
Yeah. So when we started the adventure, sorry for that. We did all the resources, we provisioned it in a manual way, but with the knowledge of the current situation, I would already start with doing that in using infrastructure as code. So, for instance, by using Terraform.
Yeah. Would it take to see the first results, in your opinion? Would it take longer or shorter amount of time, this infrastructure as code approach, to start with?
Without the knowledge of the current date, of course, it would take much longer. But I think it's worth it, and it pays off on long term. So also we had to do several other cloud migrations with different platforms. So we started that with Azure, but we also needed to do that in the very same way for the Google Cloud Platform and also for AWS. And there for us, it was clear to start with Terraform and don't do anything in a manual way. Because you will forget it. You will forget about the configuration. I don't know any developer who likes documentation, and there would be the danger of forgetting the configuration, and at some point of time the customer asks you to please provision it again in the very same way, and then you are much faster if you have your configurations in code.
Yeah. Thank you for that answer. And we move to Onur Yasalar is asking, so what is your approach to disaster recovery in Azure, especially for AKS? If active passive cluster approach, how do you sync your deployments on the passive cluster?
To be honest, I don't have that much knowledge with regard to disaster recovery currently. So I think at least I'm not at that level. So it's my task to provision it, but to be honest, to do the operation, there we have other colleagues which have much more knowledge about that, and therefore I'm afraid I can't give a good answer of that.
Okay, no worries. Thank you. On one of the last slides, you were mentioning that there was an advice to monitor cloud costs. That's a very typical issue at any project which is going cloud when they don't have an existing cloud experience. And then typically the first thing seems like, whoa, cloud is so expensive. In those instructions, in advices, you said monitor, but how you made some kind of a balance sheet, how you calculated, is it gonna now cost you 5 times more than it was before the project? What are the trade-offs? Can you talk around that a little?
I think the starting point would be to do some kind of upfront estimation. There exists, for instance, in Azure, the Azure pricing calculator, in which you can do a lot of settings. So, for instance, with regard to the Kubernetes cluster, which node size would you like to have? How many nodes would you like to have? Should it run for a whole month in a row, or for just one day, which could give you some kind of very first estimation. And then the next thing would be so if you start already from scratch, as we did, to simply try to monitor that with the out-of-the-box features in Azure, in which you get a forecast of the current computing stuff which you do. You can set alerts and we are also doing a lot of experiments, whether it's how would be the best, for instance, having, for instance, more nodes or having a better size of a node to get the calculation done. But it's in general, it's some kind of, it's a tricky part, I think, from my point of view.
Mm-hmm. Yeah. All right. Thank you, Patrick. We're out of time and questions. See you in further sessions. Thank you for the talk. Very insightful.
Thank you too. Thanks for having me, and have a great conference.
Thank you. Bye, and let's move on. And everyone who's listening, please leave some feedback.
This is all we got. Remember the revolution in our minds. This is all we got. Lock me out of this life institution. I am angry and I on illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh, we don't need to say we're sorry. We don't need to worship heaven's stars.